Hello students, welcome to this lecture, One Probability. So in this lecture, we will discuss exercise 14.1, and this lecture basically continuation of the previous lecture. Okay, so in our previous lecture, there we have studied exercise 14.1. There we have solved some problems, one exercise 14.1. Okay, and in this lecture, we'll continue that. So here we have question number 17. So in question number 17, here we have a lot of 20 bulbs that contain 4 defective ones. One bulb is drawn at random from the lot. Then what is the probability that this bulb is defective? Okay. And then secondly, we suppose the bulb drawn in 1 is not defective and is not replaced. Then now one bulb is drawn at random from the rest. Then what is the probability that this bulb is not defective? Okay, so let us solve this problem. So first of all, let us solve first one. So here total number of bulbs is equal to 20 and total number of defective bulbs is equal to 4. So probability getting a defective bulb, this is equal to number of favorable outcomes divided by number of total possible outcomes. That is equal to 4 by 20 and this is equal to 1 by 5. Okay, so probability getting a defective bulb, this is equal to 1 by 5. And then we will solve second one. So in second one, here remaining total number of bulbs is equal to 19. Okay, and remaining total number of non-defective bulbs is 16 minus 1, that is equal to 15. Okay, so remaining total number of non-defective bulbs is equal to 15. Now probability getting a not defective bulb, this is equal to 15 by 19. Okay, so probability of getting a not defective bulb, this is equal to 15 by 19. And now let us move to next problem. So in next problem, here we have a box contains 90 discs which are numbered from 1 to 90. Okay, if one disc is drawn at random from the box, then find the probability that it bears a 2-digit number. Okay, and second a perfect square number, and a third a number divisible by 5. Okay, so here we have to find the probability that it bears a 2-digit number. Okay, then we need to find the probability that it bears a perfect square number, and then we'll have to find the probability that it bears a number divisible by 5. Okay, so let us solve this problem. So here total number of discs is 90. Okay, so total number of discs is equal to 90 and total number of 2-digit numbers between 1 to 90 is equal to 81. Okay, so 1 to 90, there 1 0 1 2 3 4 5 6 7 9, they are not two digit numbers, and 2-digit numbers start from 10. Okay, 10 to 90. Okay, and the total number of 2-digit numbers between 1 to 90 is equal to 81. Okay, so probability getting a 2-digit number, this is equal to 81 by 90 and this is equal to 9 by 10. Okay, so therefore the probability getting a 2-digit number is equal to 9 by 10. Okay, and now let us find probability of getting a perfect square. Okay, so perfect square between 1 to 90 are 1, 4, 9, 16, 25, 36, 49, 64 and 81. Okay, so therefore total number of perfect square between 1 to 90 is 9. Okay, so probability getting a perfect square, this is equal to 9 by 90, that is equal to 1 by 10. Okay, so therefore probability of getting a perfect square is equal to 1 by 10. And now let us find the probability of getting a number divisible by 5. So first of all, we need to find the numbers which are divisible by 5 between 1 to 90. Okay, so numbers that are between 1 to 90 are 90 and divisible by 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85 and 90. Okay, So therefore total numbers divisible by 5 between 1 to 90 is equal to 18. So probability of getting a number divisible by 5 is equal to 18 by 90, that is equal to 1 by 5. Okay, so therefore probability of getting a number divisible by 5 is equal to 1 by 5. Okay, so now let us move to next problem. So in next problem, here we have a child has a die with whose 6 faces. So the letters as given below: A, B, C, D, E, A. Okay, so the die is the die is thrown once. What is the probability of getting A and D? Okay, so let us solve this problem. So total number of possible outcomes when the dice is equal to 6. So you all know about this. Okay, so there are 1, 2, 3, 4, 5, 6. So total number of facing having A, 1 each is equal to 2, and then probability getting A, this is equal to 2 by 6, and this is equal to 1 by 3. And total number of faces having D, 1 each is equal to 1. Okay, so here total number of faces, the total number of faces having D, 1 each is equal to 1. So now probability of getting D, this is equal to 1 by 6. Okay, so now let us move to next problem. So in next problem, here we have, suppose you drop a die at random on the rectangular region shown in this figure, that 14.6. Okay, what is the probability that it will land inside the circle with diameter 1 meter? Okay, so we need to find probability that it will land inside the circle with diameter 1 meter. So let us find the probability. So here area of rectangle, that is length into breadth. Okay, so area of rectangle is L into B. Okay, and this is equal to 3 into 2, and this is equal to 6 meter square. Area of rectangle is 6 meter square, and area of circle of diameter 1 meter is equal to 5 r square, that is equal to 5 into 1 by 2 square, that is equal to m square by 4. Okay, so area of circle is equal to m square by 4. So now probability die will land inside the circle is equal to 5 by 4 divided by 6, and this is equal to 5 by 24. Okay, so this is the probability of probability that it will land inside the circle with diameter 1 meter. Okay, so now let us move to next problem. So in next problem, here we have a lot consist of 144 ball pens, of which 20 are defective and the others are good. Okay, so Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? Okay, and then what is the probability that she will not buy it? So student, here we have lot of the total number of pens is 144. Okay, and total number of defective pens is equal to 20. So total number of good pens is what? So total number of good pens is equal to 144 minus 20, that is equal to 124. Okay, so total number of good pens is equal to 124. So now probability of getting a good pen is equal to 124 divided by 144, and this is equal to 31 divided by 36. Okay, so probability of getting a good pen, this is equal to 31 divided by 36. Now probability Nuri buys a pen is equal to 31 by 36. And now we need to find probability Nuri will not buy a pen. Okay, so probability Nuri will not buy a pen, this is actually equal to 1 minus probability of getting a good pen, that is probability of Nuri buys a pen. Okay, so we here find the probability Nuri buys a pen, that is equal to 31 by 36. Okay, so now probability Nuri will not buy a pen, this is equal to 1 minus 31 by 36, that is equal to 36 minus 31 by 36, that is equal to 5 by 36. Okay, so therefore the probability Nuri will not buy a pen, this is equal to 5 by 36. Now let us move to next problem. So in next problem, here we have to refer to example 13. Okay, so here we refer to example number 13. You will see in NCERT book. Okay, So complete the following table. So here even sum on 2 dice, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and probability 1 by 36, 5 by 36, and 1 by 36. A student argues that there are 11 possible outcomes: 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, and therefore each of them has a probability 1 by 11. So do you agree with this argument and justify your answer? So let us check. It can be observed that to get the sum as 2, possible outcome is equal to 1 comma 1, and to get the sum as 3, possible outcome is equal to 2 comma 1 and 1 comma 2, and to get the sum as 4, this is possible outcomes are 3 comma 1, 1 comma 3, and 2 comma 2. Okay, so to get sum as 2, possible outcomes 1 comma 1, to get sum as 3, possible outcomes 2 comma 1 and 1 comma 2, and to get sum as 4, possible outcome is equal to 3 comma 1 comma 1 comma 3 comma 2 comma 2. So here to get the sum as 5, possible outcomes are 4 comma 1, 1 comma 4, 2 comma 3, and 3 comma 2. Okay, now to get the sum as 6, possible outcomes 5 comma 1, 1 comma 5, 2 comma 4, and 4 comma 2. Okay, and to get sum as 7, possible outcomes are 6 comma 1, 1 comma 6, 2 comma 5, 5 comma 2, 3 comma 4, and 4 comma 3. And to get the sum as 8, possible outcomes is equal to 6 comma 2, comma 2 comma 6, comma 3 comma 5, and 5 comma 3. Okay, and then to get the sum as 9, possible outcomes is equal to 3 comma 6, comma 6 comma 3, 4 comma 5, and 5 comma 4. Okay, and to get the sum as 10, possible outcomes is equal to 4 comma 6, 6 comma 4, and 5 comma 4. Okay, and to get the sum as 11, possible outcomes are 5 comma 6 and 6 comma 5. Okay, and to get the sum as 12, possible outcomes is equal to 6 comma 6. Okay, so here we get some possible outcomes. To get the sum as 2, to get the sum as 3, to get the sum as 4, to get the sum as 5, to get the sum as 6, to get the sum as 7, to get the sum as 8. Okay, and then to get the sum as 9, to get the sum as 10, and to get the sum as 11, and to get the sum as 12. Okay, so now even sum of 2 dice, 2, the probability is equal to 1 by 36. Then even of 2 dice, when 3, then probability 2 by 36. And since possible outcomes for to get sum as 3 are 2. Okay, and total number of possible outcomes is equal to 36. Okay, so even sum to 2 dice to get as sum 3, probability of to get sum as 3 is equal to 2 by 36. And then to get sum as 4, there are possible outcomes 3. So therefore probability of to get sum as 4, this is equal to 3 by 36. Okay, and to get sum as 5, there are possible outcomes 4. So therefore probability of to get sum as 5, this is equal to 4 by 36. Okay, and then to get sum as 6, this is there are possible outcomes as 6. So therefore probability of getting to get sum as 6 is equal to 5 by 36. Okay, and then to get sum as 7, there are possible outcomes as 6. So therefore probability of to get sum as 7 is equal to 6 by 36. And to get sum as 8, there are possible outcomes are 5. Okay, so therefore probability of to get sum as 5 to get sum as 8 is equal to 5 by 36. Okay, and to get sum as 8, there are possible outcomes as 5. Okay, so therefore probability of to get sum as 8 is equal to 5 by 36. And then to get sum as 9, there are possible outcomes are 3. So therefore probability 2 gets sum as 9. This is equal to 4 by 36. And 2 gets sum as 10. There are possible outcomes are 3. So therefore probability 2 gets sum as 10. This is equal to 3 by 36. Okay, and 2 gets sum as 11. There are possible outcomes are 3. So therefore probability 2 gets sum as 10. This is equal to 3 by 36. Okay, and 2 gets sum as 11. So probability of 2 gets sum as 11. This is equal to 2 by 36. And probability of 2 gets sum as 12. This is equal to 1 by 36. So now probability of each of these sums will not be 11. Okay, so probability of each of these sums will not be 11, as these sums are not equally likely. Okay, so this is not, so the each of them has a probability 1 by 11. This is not a true argument. Okay, this is not a true argument, and I am not agree with this argument. Okay, so now let us move to next problem. So in next problem, here we have a game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Okay, so Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. So now calculate the probability that Hanif will lose the game. Okay, so let us solve this problem. So here the possible outcomes are head, 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 tail, 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 head, head, tail, head, tail, head, tail, head, head, tail, tail, head, and tail, head, tail, and head, tail, tail. Okay, so number of total possible outcomes is equal to 8, and number of favorable outcomes is equal to 2, that is tail, 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 and head, head, head. So probability Hanif will win the game, this is equal to 2 by 8, that is equal to 1 by 4. Okay, so probability of Hanif will win the game, this is equal to 1 by 4, and probability Hanif will lose the game, that is actually 1 minus probability Hanif will win the game, that is actually equal to 1 minus 1 by 4, and this is equal to 3 by 4. Okay, so probability Hanif will win the game, this is equal to 1 by 4, and the probability Hanif will lose the game, this is equal to 3 by 4. And now let us see question number 24. So in question number 24, here we have a die that is thrown twice, and what is the probability that 5 will not come up either time? Okay, and second, 5 will come up at least once, and here we have given some hint. So here throwing a die twice and throwing 2 dice simultaneously are treated as the same experiment. Okay, so first of all, we need to find what is the probability that 5 will not come up either time, and then we need to find the probability of 5 will come at least once. Okay, so let us solve this problem. So here total number of outcomes is equal to 6 times 6, since the die is thrown twice. Okay, and the total number of outcomes, this is equal to 6 times 6, that is equal to 36. And now total number of outcomes when 5 comes up one either time are 5,1, 5,2, 5,3, 5,4, 5,5, 5,6, 1,5, 2,5, 3,5, 4,5, and 6,5. Okay, so these are all possible outcomes when 5 comes up one either time. Okay, and hence total number of favorable cases is equal to 11. Okay, so total number of favorable cases is equal to 11. So now probability 5 will come up either time, this is equal to 11 by 36. Okay, and now probability 5 will not come up either time, this is equal to 1 minus probability of 5 will come up either time, that is equal to 1 minus 11 by 36, and this is equal to 25 by 36. Okay, so probability 5 will come up either time, this is equal to 11 by 36, and probability 5 will not come up either time, this is equal to 25 by 36. Okay, so now probability 5 will come up at least once, this is actually equal to 11 by 36. And why? because total number of cases when 5 can come at least once, this is equal to 11. Okay, so therefore probability 5 will come at least once, this is equal to 11 by 36. And now let us see question number 25. So in question number 25, here we have which of the following arguments are correct and which are not. Okay, so give reasons for your answer. So first argument: if two coins are tossed simultaneously, there are three possible outcomes: two heads, two tails, and or one of each. Okay, therefore for each of these outcomes, the probability is 1 by 3. Okay, so let us check first statement. So here, so basically this question is a form of problem. Okay, so in second statement here we have, if a die is thrown, there are two possible outcomes, an odd number or an even number. Therefore the probability of getting an odd number is 1 by 2. So student, which of the following arguments are correct and which are not correct? Give reasons for your answer. Okay, and this is your homework problem. Now here we'll discuss summary. Okay, so in this chapter we have studied the following points. First, with the theoretical or classical probability of an event, written as probability of E, is defined as P of E. This is equal to number of outcomes favorable to E divided by number of possible outcomes of the experiment. Okay, so we have studied in our theory class. Okay, so the theoretical probability of an event E, written as P of E, and is defined as P of E is equal to number of outcomes favorable to E divided by number of possible outcomes of the experiment, where we assume that the outcomes of the experiment are equally likely. Okay, so the outcomes of the experiment are equally likely, that we have assumed. And second point, we have studied in our previous lecture, the probability of a sure event or certain event is 1. Okay, so the probability of the event which must be happen. Okay, which must be happen, that event is called sure event or certain event, and the probability of a sure event is 1. Okay, and then we have studied in our previous lecture, the probability of an impossible event is 0. Okay, so what is impossible event? When an event that cannot be possible to happen. Okay, that event is called impossible event. So the probability of an impossible event, this is equal to 0. And fourth point, we have studied in our in this chapter, the probability of an event E is a number P of E such that 0 less than equal to P of E less than equal to 1. That means probability of an event E is always lies between 0 and 1. That means probability of E, this is always greater than or equal to 0 and less than equal to 1. Okay, so probability of E, this is always greater than equal to 0 and less than equal to 1. And an event having only one outcome is called an elementary event, and the sum of the probabilities of all the elementary events of an experiment is 1. Okay, so we have studied in our previous lecture, there we have studied the probabilities of all the elementary events of an experiment is 1, and there we have also studied what is elementary event. So an event having only one outcome is called an elementary event. Okay, and for any event E, probability of E plus probability of E var is equal to 1, where E var stands for not E, and E and E var are called complementary events. Okay, E and E var, they are called complementary events. And a note to the reader, the experiment for empirical probability of an event is based on what has actually happened, while the theoretical probability of the event attempts to predict what will happen on the basis of certain assumptions. Okay, as the number of trials in an experiment go on increasing, we may expect the experimental and theoretical probabilities to the nearly the same. Okay, so not from the examination point of view, this is actually knowledge point of view. Okay, so the experiment or empirical probability of an event is based on what has actually happen, while the theoretical probability of the event attempts to predict what will happen on the basis of certain assumptions. Okay, as the number of trials in an experiment go on increasing, we may expect the experimental and theoretical probabilities to be nearly the same. Okay, so I stop here this lecture. Thank you very much to all of you.